Hi, this is Twitter Think, and in this one we are going to talk about finding the Laplace transform of f of t equal to e to the power at, an exponential function to the power at. And in the previous video we talked about introduction to Laplace transform, and we added Laplace transform of a function f of t equal to a. You have to look at that one and then come here. There are a series of videos under this topic in this same playlist. My name is Daniel. Please subscribe to this work. I know you have not. I'm giving you a second to do that, and let's box on to what we have today. So in this one we learned that the Laplace transform of a function is given by Laplace transform L of f of t, giving us the integral of the lower limit 0 and the upper limit infinity. We learned that the real value 0 up to infinity are values for t, and it is given by finding the product of the Laplace transform f of t and e to the power negative st dt, where s here is a constant, which is a complex number large enough to convert the product of this and this towards 0 when t approaches what? Infinity. This is first derivative of t, and t here is a real number that is greater or equal to what? 0. So now to start, we have our f of t equal to this. So we will just introduce it inside the formula and see what will happen. So we have a Laplace transform of e to the power of at. Okay, so I'm using my curly bracket. This is not nice, but let's manage it, okay? So we move on to integral of 0 to infinity. What is f of t? We know f of t to be this. So we introduce our e at times our e minus s of t dt. Now for the sake of indices, I'm going to turn this one. Do you know multiplication is commutative? So I will turn this one just for the sake of explanation, okay? So I'll put this one here and this one there. Okay, so now we can introduce our upper limit and lower limit. But so now we can use indices to work on this. The bases are the same, so we will add or work on the what? Exponent and factorize it. So let's do that. So this is the same as integral of 0 to infinity. Now watch this very carefully. We are taking one of the base. So this is e, then we have t here, we have t here, so we factorize t out. So to do that, we will write our s minus a into bracket t. Now I'll bring out a negative one. Let me put a negative here. Now this means that when I multiply this by s, I'm getting negative s times t, which will give me what? Negative st. Then when I multiply this by this, I'll get positive at. Do we understand? Because this t here belongs to this one and this one. Do we get the concept now? dt, and that is it. So now we can now introduce our upper and what? Lower limit by integrating the function. So after integration we do that. So in the previous video I taught you how to integrate an exponential function. So let me take you through it once and then we go. So if we have e to the power, let's say at, then the integral of this is equal to 1 over a e to the power at. Okay, so if a is any random number, let's assume we have something like minus 2t or x, whatever variable you have here, then the integral of this is the same as 1 over minus 2 e to the power of minus 2t. Do we get it? So now the function that we have here, we have minus s minus what? A. Okay, so something like this, e to the power minus into s minus a times t. So everything that we have here, 1 over that result. So we have the integral of this is going to give us 1 over negative s minus a. Okay, e to the power the same negative s minus a t. Do we get it? Very, very simple for you to understand. Okay, so please let's apply that result here. So the integral of this is giving us, now let's integrate this. We have 1 over minus s minus a, then we introduce our upper and lower limit times e e minus s minus at all to the power 0, and this, no, not to the power but to the upper and then the lower limit. So now we have integrated the function. You get rid of what? dt. It is gone. Now let's put in our 0 and infinity. So we have to substitute t for what? 0 and t for infinity. Remember that for integration, introducing the lower and the upper limit is upper limit minus the lower limit. So this result is going to give us 1 over negative s minus a times, to introduce it, we put in the upper limit first. We have e, let me put this in brackets, e minus s minus a times t. And remember that our t is outside, so we introduce what? The infinity sign. We close the bracket minus the lower limit. We repeat the same process. E minus s minus a, then we introduce our 0. We close the bracket. So this is what? 0. Now, as t approaches infinity, the result of the function converges to what? 0. But to this one, when we raise to the power 0 on the right side, the result is 1. Remember that a variable to the power 0 is 1. So for instance, s to power 0 is 1. So when we have e to whatever, because it is raised to power 0, the result is what? 1. But not just an ordinary 1, but a negative what? 1. So now the result here is equal to 1 over negative s minus a times, now everything we have here is 0 because of this. So we have 0 minus everything we have here is 1. All right. So in your next step, all you need to do is use this to multiply 0. Use this to multiply what? 1. So this is the same as what? All the results here times 0 is still 0. We don't need it. So now all the results here is a negative result. So when we multiply by a negative 1, the result becomes a positive 1. So not 1, a positive function. So now we are having this times 0, this times 1, giving us 1 over s minus a. And this is the result. And let me put this in brackets. So the Laplace transform of the function e to the power at is equal to 1 over s minus a. Very simple. Remember that I can substitute a value for a. For instance, if I put 2, then the result will become 1 over s minus 2. So now let me take an example for that. I'm not going to solve. I'll just put the values in. When you are given the Laplace transform of, let's say, e to the power 3t, you treat it the same way. So there is no need for me to solve this. We know that the Laplace transform of e to the power at was giving us 1 over s minus a. So when you solve this, the Laplace transform result becomes 1 over s minus 3. Do we get it? So now the Laplace transform of, let's say, e to the power minus 2t. Remember that this value is negative. So if this is negative, this sign will change. So for this, when you solve, the result is 1 over s plus 2. If this side is a positive result, then this side becomes negative. All right, so that will be the end of this one. Please subscribe to this work. In my next video, I am talking about finding the Laplace transform of sine at, and then I'll talk about Laplace transform of cos at. Thank you very much, and I'll see you in the next one.